When I first sort of was looking at writing this talk, I was like, right, I'm going to write a talk on microservices. And I want to write something that people have not heard before, which is almost an impossibility in microservices. So I started to do a mind map. I started to do a bit of a brain dump of all of the things that I thought was really important with microservices. And I came up with all of that, and that doesn't even go half of the way into the depth. So I was going to cover all of that in 35 minutes, right? So seriously, it would probably take me about 35 years. So we needed another plan of attack. So what I do want to talk to you about is 4 ways to fail when implementing a microservice architecture. So my name is Nic Jackson. I'm an engineering evangelist, and I work for notonthehighstreet.com. And notonthehighstreet.com are they're kind of like a marketplace, so somewhat similar to Etsy, but we're a curated marketplace. We're a reasonable sized company. We're currently mainly about 90% of our sales are in the UK at the moment, and we're turning about 160, maybe 180 million pounds per year, which isn't a bad sort of turnover. So where we're going, though, is that we want to dominate the world. We want global domination. And to do that, we need to change. We need to break down our monolith, and we need to build out something that's just a little bit more modern and nicer. So let's look at the first way that you can fail when you're implementing an microservice architecture. So the first mistake you can make is by not enabling change. And this point is really aimed at a leadership level, because you have to look at why are you implementing? Why do you want to do this whole microservice thing? Is it you're just chasing the shiny? Because if you're chasing the shiny, then you're probably making a mistake. What you need to do is you need the leadership to be looking at the real driver behind this change. What is the business reason behind this change? What is the problem that you're trying to solve? And more often than not, it'll be because the business needs to be relevant in its current market. It needs to be able to react to the changes. It needs to be able to drive itself as a market leader. And trying to do that with some 10-year-old dilapidated piece of technology is not really going to get you very far. So microservices are a hot topic. Now, that was kind of why, but how do you do that? And how you do this is by reversing the standard leadership pyramid. So the role of leadership is one of support. So I don't really know why in this pyramid leadership is always right up on the top. And the reason that leadership should be right down on the bottom as well is because they're the ones who actually bear the brunt of the accountability. So if your leadership is not encouraging the change, if leadership is not encouraging you to sort of take the risks and to adopt this new technology, then you could be overcautious. If you're overcautious, you won't drive the change that the business needs. And they need to kind of help you to make these technical decisions and to be comfortable with making these technical decisions, because I'm assuming most of you have built microservices. And I'm assuming that if you've built microservices, you've probably been burnt once or twice, maybe 3 times. And that's okay. You know, microservices will fail, and that's okay. Because the key thing is the benefit that they're bringing to the business in terms of that speed of change, which allows, the business to react to its current market. So the second reason that you're going to fail is by not modeling your domain. So not modeling your domain, what does that mean? So there's a tendency when you look at a lot of systems, they're built around a data model. So features are added. You consistently are looking at this monolithic database, shoehorning in additional bits and pieces which shouldn't really belong there. And you're sort of treating that as actually the business domain. And that's not what it's all about. You should be looking at how the business operates and what it really needs, and then start building the technology around that. So Vernon Vaughan, who's one of the leading practitioners in domain-driven design, coins the phrase of a big ball of mud. And he describes a big ball of mud as this big, congealed, interconnected, badly built, dependencies all over the place. And he describes domain-driven design, which is a technique for analyzing these business contexts, as a set of tools that assist you in designing and implementing software that delivers high value, both strategic and tactically. Now, it's been around for a while, but nobody really took any notice until we'd all built a distributed monolith, and we realized just how terrible that was. And these 2 points, I think, really resonate, that the database is given too much priority. Most of the discussion around the solutions center around the database and the data model rather than business processes and operations. There's incorrect abstractions where developers try to address all of the current and imagined future needs by generalizing solutions. And Vaughan tries to tackle this by taking a two-pronged approach. One is a strategic design. And in the strategic design, that's when you try and avoid this. What you're trying to do is look at bounded context. And what a context is, well, I mean, that means different things to different people, but it's generally sort of an operation. This could be an orders context. Now, each of these bounded contexts, you try and describe them with something that he calls a ubiquitous language. And what that is it's basically a language that each of the teams that own each of the contexts share. It's something that's local to them. It doesn't necessarily have to have any meaning in a wider context. So you might have a case of an order. Now, an order might mean something in a payments context, but it might mean something different in a stock context, and that's fine. They don't have to mean the same thing as long as the people who are working in the context understand what they are. And we also look at things like the core domain, and the core domain is incredibly important, especially when you're trying to design this system, because the core domain is the thing that differentiates you from your competitors. It's the things that you really should be building. Now, all of the other subdomains, you should be looking and saying, well, can I buy that off the shelf? Can I choose a third-party product? You should be concentrating all of your effort on the core domain. And hopefully what you end up with after you've done this analysis is something like this, where you can see the various domains clearly identified. And what's interesting about this is not a technical map. This is a business process map. But I look at that and I'm kind of seeing microservices or groups of microservices. And that's really useful. So by taking this approach, it can really assist you from falling into that trap of creating a distributed monolith, of building that big ball of mud. As Vaughan says, he thinks that the core problem with modern development is that we try to do everything just in time. We try to sort of go hyper agile. We sort of leave the design as just a thing that we don't need to worry about. Whereas actually, if we spend the time to do this upfront design, then it gives us a much greater picture of where we're going to go with the system. This is the next mistake that you're going to make. Not having the right tooling. And there's actually 3 mistakes grouped into this one mistake. So you've got a failure of how important automation is. You've got a failure to realize that your test coverage is not good enough. And you've got a failure to realize that you don't have enough logging. So let's start with automation. So you sort of first need a good framework, right? When you're building a monolith, you might change it every 5 years. You might change it every 2 years. You might change every 10 years, like not on the high street, right? But there's a certain amount of upfront work that needs to happen when you're starting that monolith project. You put all of the work into scaffolding the project, you put all of the work into setting out your unit tests, your functional tests, you get everything set up in CI, and that takes time. I mean, that takes a decent amount of time to get it where you want. Now, if you're working on a microservice and that microservice is maybe typically 1 sprint, maybe 5 sprints, depending on what the complexity is. Do you really want to be spending 2 weeks just setting up the scaffolding every time? It's not effective. It's not an efficient way to work. So what you need is a framework that you can use to scaffold these various microservices. And in terms of tooling, there are bits and pieces kicking around on the internet, but this is something that's quite infantile in the world of microservices. So there's not really a kind of a Gradle for microservices yet. There's certainly not really anything which supports the way that a lot of organizations want to work, which is in a very sort of polyglot manner. And what I recommend is looking at some of the frameworks which are out there, choosing the best bits from them, and then actually maybe just fork it and start building something that's useful and meaningful for your business. I'm not really certain that there will be a one-solution-fits-all tooling that'll help us with this, but I think certainly there's a lot of great research that's been done around patterns and practices which we can leverage. And the patterns and the practices and getting those as standards inside of your organizations is, I cannot stress how incredibly important that is. So getting people on a common footing, no matter what language you work on, simple things like how do you call a downstream service? What's your messaging protocol going to be? Try and sort of get that as a pattern, as a grounded understanding within the team. Get everybody to contribute and get everybody to buy into it. So once you've built these software patterns, once you've got everything set up, you need to deploy the service. So in terms of DevOps, is everybody here either responsible for deploying their own services, or do they have a team to do it for them? But basically everybody's aware that it doesn't happen by magic. And actually it's a pain in the ass. Has anybody, like ECS, the latest and greatest, you believe the hype, you read it, I can just deploy a container straight from a registry, it's running in Amazon Cloud, it's infinitely scalable, and it's globally available within 3 clicks of the button, right? Do they really mention that you have to set up the cluster, set up the auto-scaling group, configure the DNS, configure the VPC, configure the subnets, add an internet gateway. What else do we need to do? Configure the tasks which are going to deploy the service, create the service definition, ELBs and ALBs. Oh yeah, we need to set those up, and we need to set the deployment groups up as well. There's something like 20 steps that you've got to go through, 20 different steps on that in Amazon's AWS console interface to get one little service deployed in ECS. Now, I wouldn't thank you if you asked me to repeat that again, and that's why automation tooling is so incredibly important. So there are tools like Ansible, there's Chef, there's Terraform, but you need to be spending the time up front to investigate these tools, choose the right ones for the team, and to get them integrated into your patterns and processes. get them running from CI. If there's any manual steps in deploying a new infrastructure, then I think you would fail. You should have it that it's all parameter driven and that you can create your environments, your staging, your production, your development at the various different sizes that you need and make it one click. So then you realize that your test coverage is not good enough. But you generally realize that your test coverage is not good enough because somebody from customer services might come along and they'll say, hey, the website's down. You say, what do you mean the website's down? The website is fine. And then you dig into it, and the website's down. And you can't understand why the website's down, because the first thing you do is you go straight onto the CI. It's like, have we had any tests which maybe have passed incorrectly, and we've had a deployment that's gone out which shouldn't have gone out? No, everything's fine. All the automation is working exactly like it should. And then you find that somebody's made a small configuration mistake, and there's a config file somewhere for production which has got the wrong value in it, and it means that a couple of your services aren't connecting properly. And then you look into that a little bit deeper and you realize that actually there's a massive hole in your test coverage. Now, when you had the monolith, your integration tests, your user journey tests were covering you because it was all in that one big box. But now you've got this massively distributed system. Those tests are only running in isolation. They're running on the individual boundaries. They're not really covering the big picture. And that's really important. So having that sort of real high-level automation test and running that, but also running that when you're in production. So run it post-deploy. Just run it as that extra sanity check. And this actually segues me nicely into my next point, because why did customer service come to tell you that the website was down? Well, that's because you didn't realize that you didn't have enough monitoring. So monitoring and logging is incredibly important. I mean, incredibly important. And it's not hard. You've just got to think about it up front, and again, do that upfront planning. So there's various different forms of logging. So we use things like New Relic, and that's kind of like for our real sort of high level. It's general health checking. We want to maybe look at response times. What's the throughput on the system? That gives us a really sort of top level view of what's going on. It's not particularly useful in terms of diagnostics though, and that's where we use Datadog, but in essence, whether you use Datadog or Prometheus with Grafana, or whether you use any of those tools, those real small, very lightweight stats which are firing out of the system all of the time. I mean, typically over like a UDP, so you don't really care, again, if you lose one or two of them. The key thing is that you've got this wealth of data and this that you can draw on. It's really, really important. I mean, things that you don't necessarily even think are important, they will be when you're trying to diagnose why a system's malfunctioning. Why is something slowing down? Well, I want to be able to drill in, and I want to be able to see that this one particular service, or even a function within a service, is running slower. Because that helps me to dive straight in, and it helps me to start diagnosing the problem and pinpoint exactly where things are happening. The other benefits to this is that you can look at this and you'll start to see trends within your systems. And you can use this for alerting. So rather than having a straightforward off and on, and what we actually do is we look at our number of transactions, and if our transactions will change over a set percentage within a given period of time, we trigger that as an alert, because we never have these sharp drop-offs, even of a certain amount. If we have a drop-off, that generally means something is misbehaving somewhere. And then, of course, you must never forget good old-fashioned logs. Hopefully the last port of call, but there's nothing worse than having to try and grep the log files of half a dozen different servers, if you're lucky enough to have them. But using something like Logstash to be able to push them all into Elasticsearch, using one of the software as a service platforms like Loggly. It gives you that great ability to be able to diagnose the problems. And I think one of the other important things which you're going to forget to do is the importance of a correlation ID. So if you've got a transaction which is flowing through a system, unless you explicitly state that you're going to have a common identifier through each of those transactions which can tie it back to a particular customer action, you can be a little bit lost looking through those logs. Putting in a simple correlation ID means that you can actually start grouping the logs across the various different servers and services into a group of transactions. And lastly, this is probably the biggest mistake that an established organization can make when it's changing to a microservice architecture. It's not breaking up the monolith. It's not spending the time to understand actually what you have. Because you can look at a couple of different approaches. There's the approach that you're going to do this incremental rollout of the new system, or you can do the Big Bang approach. The Big Bang approach, it will overrun in time, it will underrun on features, and it will overrun on cost. Probably by the time you release it, the technology is going to be out of date. The market will have moved on, so you're actually maybe not even delivering business features which are required anymore. So this is actually quite important. It's an important strategy to be able to deliver the business value as you're working on the services. Get them in straight away. You can run an A/B test on your system with the old and with the new. You can test that it's functional, you can lower risk. How you do that is not a trivial matter. Now, Sam Newman, read Sam Newman's book, Building Microservices?
Yeah.
Fantastic book. And Sam talks about the concept of a seam. And the seam is a place where you can start to introduce the new code into the system. And it was proposed, I think, pre-microservice, and was actually looked at a way that you could introduce a new library into an existing application. But Sam proposes that you can actually take a three-step approach to introducing these seams into your services. And the first one is that you start off with your monolithic structure, and the second is you start breaking up the databases. Once you've got separation of code and database, then it's actually quite simple to break it out into two separate independent services. I think Sam is a little bit over-optimistic on the state of a lot of code bases when he proposes this. And I think actually what you need to do is you need to do a whole bunch of upfront refactoring to actually decouple the code before you can decouple the data. And it's definitely worth spending the time on doing this, because what you're doing is you're making the surface area of where you need to introduce the seam a lot smaller. You're introducing a sort of a smaller level of dependency throughout your spaghetti ball of mess. And that takes time, and that's a hard sell, but it's absolutely essential. And if you succeed in doing that, then actually, once you've established that pattern, once you've got used to that as a pattern, you will literally be able to be rolling out those microservices so much faster. You might need to persuade some people to do that work, because there's probably not many software engineers who want to spend their time working refactoring an ugly code base, especially one which has got fragile tests. But it's actually an interesting piece of work, and it actually requires quite a decent level of engineering expertise to be able to do that. So how are you going to throw all of these services together? So what you're probably going to do is you're just going to build a RESTful service, and you're just going to connect them all together synchronously, And then you're going to sit back and wonder why it's taking 3 times to make exactly the same call. And you're going to probably wonder why you're getting a lot more errors. And the reason for that is because of the sort of fragile nature of microservice environments. You should design for non-availability. You should always assume the worst. And when you're using patterns like REST, then that's fine. REST is easy to understand. It's quite semantic. JSON is, again, easy to understand. It's quite semantic. It's also not particularly quick. Now, especially using standard HTTP, you've got the handshake. If you're using SSL as well and you're doing interconnection internally, then there's another layer of stuff. And what you should actually be doing is asking yourself, how many of these need to be synchronous calls? How many of these can I actually just fire out later on? Like, if I don't care when it happens, as long as you get at least one delivery, do you really care? And I'm not going to dwell too much on this, so it's always been fairly well covered, but an event-based architecture, it's going to be absolutely central to a good microservice approach. And it's something, again, you should think up front, along with the patterns that you're going to use internally. Do you really need to use REST for service-to-service communication? The world is not like J&I anymore. You've got protocols like Thrift and Service, protobufs. There are binary protocols which are heavily, really usable, binary protocols with descriptive contracts that you can actually share, and stuff which will do a lot of code genning. So some further reading. If anybody's ever tackled any of Vernon Vaughan's books, then his latest book, Domain-Driven Design Distilled, is actually okay. If anybody's only ever read Eric Evans and finished it, then this is an absolute dream. It's actually a really nice book. It covers the sort of the high-level concepts of DDD, and it's very accessible for a very wide audience. Building Microservices, Sam Newman's book, that is gospel. It is a fabulous book. Again, high-level concepts, but it's enough to give you the information to dig a little bit further. And Release It by Michael Nygaard. This is an older book. I think this is maybe almost 10 years old now. But there's some really nice patterns in there, some of which I think probably Sam Newman draws upon, and it's well worth reading. Community resources. Community is awesome, and I'm really, really pleased to see another kind of West London community, which I have to say I didn't even know exists, and I am pleasantly pleased that it does. Just to sort of point out a couple of other communities which are in the area. There's Wild West Tech Talk, which is predominantly kind of Richmond-based, but quite often will get about. Richmond New Tech. Richmond New Tech is maybe a little bit more sort of leadership level. Wild West Tech is more Cody level. And we've just started a West London Slack group, literally on Friday, I think it was. So please register for that, because it'd be great to bring everybody together in West London as a community and to get us sharing a little bit more and get more of these awesome events happening. So I missed a book off there, but there's an amazing book coming out called Building Microservices in Go, and it's written by a guy called Nic Jackson. It'll probably be out in February, and it'll be released on Pact, and I'm really poor, and I need the money, and my kids are starving, and there's loads of great information in it. But seriously, thank you very much. You can find a whole bunch of stuff from me there. On the Slack channel, obviously. I love to talk. And any questions?
Well, you showed quite a few diagrams where you break up a monolith into subcomponents or isolate them as microservices, both at microservices level and then like a big chunk schema. So sometimes when you do this sort of refactoring, you meet components that just belong to everywhere.
Yeah.
What do you do with this?
Accept it. I think so.
Do you mean you clone them throughout all dependent?
I mean, are you talking like on a library level?
Well,
like say authentication
well,
or
you
something?
have your own library.
Yeah.
Your own code that you develop, like, I don't know, in a database parlance that would be, let's say if we talk about a transaction, the transaction ID, it will be everywhere.
Yeah.
What do you do with that?
So Netflix, when they talk about the distributed monolith and they look at the way that they've built their systems, they have one core library or maybe a couple of core libraries, which is shared by just about every single service, and that's predominantly like their Hystrix library, which is responsible for managing downstream connections. And they looked at this and they said, we don't like the fact that we have this shared library, which is running on all of our services. But they realize that actually sometimes it's just a necessary evil. It's not a bad thing to do. I think what you've got to consider is that you avoid the concept of having to deploy the entire estate because of one library change. And if you do need to do that, for example, because of a security issue in a crypto library, that you can do it on a rolling basis and that you don't actually need to stop everything, have everybody stay up until 2 o'clock in the morning, swear until 7 o'clock because it hasn't come back up again, panic until 9 o'clock when the CTO comes in, and then pretend like there's never been a problem. I think it's okay. I think you've just got to take a sort of a sensible and pragmatic approach to how you version the library by ensuring that the contract and the behavior of the library doesn't necessarily change, and if it does, then that's actually a major version bump. Does that answer your question?
Yeah, very much so.
Okay. Any other questions?
Regarding languages and microservices, how do you welcome diversity of languages and data stores and language repository? Is it a good thing to do? Let your developers just use the language they like, or
so
try and enforce like JavaScript?
I believe so. I believe it's about ownership. So with if we think of a service, or if we think of it maybe as a context, then what it's a good idea to do is have a team which owns that service. Now, that doesn't necessarily mean that other teams can't modify it, but you have an owner. They're responsible for it. So because they're responsible for it, you can leave it up to them to choose what it's written in. So if somebody decides, hey, I want to write a Haskell service or Erlang, then as long as I'm not the guy who's getting out of bed at 2 o'clock in the morning when it goes bent, I don't care. I think it allows the team to be innovative, and it allows them to be creative, and it allows them to further their own learning, and also to choose the best tools on the job rather than being prescriptive about a set of frameworks or languages. I think you can run a risk that it can become too diverse, but in my experience, it kind of stays sensibly restrained as long as people are aware of that one concept, that they own this thing. And again, if the microservices are small enough, then actually it might not be that much effort to just rewrite the thing. So somebody decides to write a microservice in Crystal or some other new sort of hipster language, and actually the performance is awful or the support fails on it. If you can just rewrite it in a couple of weeks, then yeah, you know what, maybe it's okay. So we work in a diverse number of languages. So we will work in Go. We've got microservices in Swift 3. We've got microservices in Node, Ruby on Rails, Java. So we've also got, I think it's called Hanami now, which used to be the Lotus framework. And I think there's probably some Python stuff kicking around as well. And for a team of about 50 software engineers, that's perfectly manageable.
You know, you said REST is not ideal, but, and also REST is synchronous.
Yeah.
But not really. You could implement asynchronous with REST, and also HTTP2 is coming up.
Yeah.
You can get all the benefits.
So HTTP2 has huge benefits. I mean, the fact that you don't have to go through the handshake process every time, it's incredibly fast. So I've been doing some benchmarks recently, looking at a various different number of frameworks and looking at different things from JSON over HTTP to binary over WebSockets or JSON over WebSockets, gRPC and protobufs, which is probably my latest favorite. The performance on that is astounding. I think that the reason that I sort of say that about REST is that for a long while, REST was the only option. It wasn't the safety option. It was kind of like the only real option. The only way that you could have like a common interface with multiple languages and multiple systems without actually having any real sort of bespoke code. With you've got the huge amount of support in the libraries. You've got the capability of running things on the client. But there's libraries now. I don't know whether protobufs. There's definitely protobuf generation for Node and JavaScript. So if you were running an HTTP, let's say an HTTP2 service or WebSockets, and you were using protobufs as your messaging, then that actually could give you an incredibly efficient service. So what does that mean? It means that if you've got an efficient service which can sustain not necessarily a huge amount of concurrent connections, but can deal with a huge amount of requests per minute or requests per second, you can lower your requirements on your architectural infrastructure needs, but you're also improving your response times for your client, which can actually have a direct impact on conversion if you're working in an e-com world. So I don't think REST is dead by any means. I genuinely love REST. I love the semantic nature of using HTTP verbs to describe an operation. But I definitely think there are changes happening which mean that we should start looking around and actually identifying if there's a better way to do things.
But you can still use portable Avro drive.
Yeah.
So it's just a way of transporting data.
Yeah, I mean, protobuf is the message. The underlying transport could be anything. Anything you want. And I mean, there's a huge number of benefits of using HTTP as a transport. Probably the single most, when I look at a lot of things, is that if you're using some sort of bespoke pure TCP or UDP-based connection, then you're going to run into problems around load balancing. You're going to run into problems around caching. You can't necessarily leverage a CDN in the same way as you can sort of leverage it with HTTP. So yeah, I'm not anti-HTTP. Don't get me wrong. HTTP2 is definitely going to be a game changer, I think. And if you use Go, you get that out of the box. In fact, you've had it out of the box for about a year, so it's pretty awesome.
Now that you're talking about protocols and you're talking about communication, what do you think about GraphQL? Because GraphQL is designed to talk with different microservices and return one single request and push. What's your thought on that? Do you think it's great? Do you think it's just
So I haven't looked at it personally. It's definitely on my radar as something that I'm incredibly interested in, because I stand here today and we're talking about microservices. My deep-held belief is that actually microservices are dead, and that technologies like GraphQL and Lambda in a few years will be completely taking over. Now, there's certain problems and complexities with those at the moment, but I think the ability to actually define an API and to hook that up to a GraphQL and immediately have a functional sort of CRUD-based API is incredibly powerful. It cuts out a lot of the middlemen. It's also incredibly scalable. Yeah, I think GraphQL could quite possibly be a real hot thing to watch. I think like all of those things, like serverless and GraphQL, there are still problems with the development flow. So like the serverless framework for Lambda attempts to solve a lot of problems by giving you the capability to run your tests and spin it up locally and to kind of perform that kind of thing that's useful rather than having to sort of wire it up and deploy it onto Lambda. But it's...
At the end, what you say, you need to be able to change all the time, right? So it's some part of your to change. You want to reflect this immediately into all your service layer up, right?
I mean, for me, when I look at things in e-commerce, the most interesting sort of area around flexibility and scale is that the load we receive is quite variable. So we don't always get a very predictable pattern. Sometimes certain areas of the site will be taking greater hits than others. Sometimes we sort of experience pressure in the payments gateways. Sometimes it might be in search. Whereas commonly with a sort of monolithic approach, and in some ways that we're kind of maybe not doing so well with our microservices, is that we sort of scale those as a unit. We assume that there's a factorial increase across the entire of the estate when it isn't. And using tech like GraphQL and serverless gives you the capability to have that very, very sort of granular level of scale, which again improves performance and lowers your costs, and that's got to be a good thing. And rapidity of speed of development as well, being able to quickly prototype things. I think we shouldn't forget how important that is, being able to get things out to the customer and being able to test them.
Place of Docker, of containers in your architecture? Is there room for that?
Yeah, we use Docker heavily. I love Docker. In fact, I'm already sad to see the death of Docker, even though it hasn't yet happened. But I'm kind of mourning it already because I genuinely love it. What Docker means for me is the capability to spin up a service without actually having to compile it. Without having to install like half a dozen dependencies, like maybe I need Apache, maybe I need, I don't know, a Java server, maybe I need some Rails backend or half a dozen different databases, data stores, and event messaging. I can model my stack using something like Docker Compose, and I can actually pull the production containers and run them on my local machine. I think that's an important point when you're using Docker, is that you shouldn't have a concept of this is a dev container, this is a test container, and this is a prod container. You should just have a prod container. Any changes should be config driven. There should be no changes which happen on a code level, because that gives you a much truer representation when you're running any debugging or any tests or anything like that. Docker is also incredible for, I mean, I joke about ECS and it being a bit of a pain in the backside to deploy a service. But a lot of that is kind of like a one hit. And to be honest, once you've written a couple of scripts in Terraform, it is fairly straightforward. And actually, if you use something like Docker Cloud, then all you need to do is push your container to the registry, and they've got auto deploy mechanisms. And orchestration is getting a lot better. We don't actually use ECS for anything other than development, not on High Street. We are still firmly in Mesos and Mesosphere, and we've been using that for about 18 months now, and we're more than happy with it. So yeah, Docker is huge, and just use it for everything. Like literally everything. If you haven't created yourself a Docker container that's got your own special version of Vim with all of your plugins running in it, then don't sleep tonight, do that. Any other questions?
You spoke about gRPC. What language are you trying? Is it Go, just Go?
So I've tried it in with Go. I've tried it with Ruby. I'm going to be trying it with Swift, well, not gRPC, but protobufs with Swift tomorrow. Java. I've used it from Java on both Android and sort of just vanilla Java. So for apps, I think gRPC is incredibly interesting because the ability to have like that bidirectional stream is really useful for having a very sort of fast data update. So like something like Twitter or maybe email or stock tickers, things like that, being able to have those very light, fast binary messages coming down to your phone with that constant connection can actually dramatically improve the performance, especially when you may be out and about and in a slightly dodgy 3 or 4G area, like one of the most fundamentally large financial capitals on the planet. Any other questions? Oh, sorry.
A word about service discovery.
Oh, yeah.
How do you describe all these microservices? Who should talk to who, and
Yeah.
how do you store this?
So service discovery is a very interesting area. And by interesting, what I actually mean is should be unnecessary. So I don't believe that I should actually have to do service discovery. I don't understand why there isn't necessarily something that I can get out of the box which does all of this for me. And there is movement towards this. So what we use is, we use Console, which is by HashiCorp. And we use Console because we actually use it for as a dynamic service registry, but we also use it as a key value store for just storing configuration and things like that. And Console's a pretty nice piece of kit, but you still have to deal with a lot of the sort of the mechanisms. There's still a huge amount of like boilerplate, unnecessary sort of boilerplate that you have to go to. So I need a client which is capable of handling service discovery. So do I build that into the client, or do I use something like console template or console env, or what I think is a more interesting pattern, Giant's container pilot, which uses their autopilot pattern, which is about having a not kind of like a daemon runner, but something which is responsible for checking that the service is available, that it's responsible for registering it with the back end, and then actually absolving the knowledge of service discovery from your running containers altogether. There's some interesting stuff moving around that. So Swarm by Docker have got some interesting sort of, I've had a little bit of a play around with it. It seems to just use DNS service SVRC records in the same way as you get when you run a sort of a Docker link. It's still backed by console or etcd or something like that, but in my humble opinion, there's too much boilerplate needed with service discovery in the industry at the moment, and we kind of need something that's a little bit easier. So there's a startup over in San Francisco called DataWire, and DataWire are sort of trying to deal with that service contract, service discovery layer for you in your microservices. So their code-generated clients will provide things like circuit breaking, load balancing, and service discovery. And again, it works on a sort of a mass of different languages. So I think it's an evolving space. But whether we do Lambda or whether we do microservices, service discovery is a definite problem for which I wish I would say I had a perfect solution. But Console's about our favorite so far. Thank you so much.